Analysis report, primes, composite numbers, and the golden number phi. Section 1. Main thesis or claim. The video presents a new hypothesis for primes and composites. The central claim is that there is a specific, quantifiable relationship between the distribution of prime and composite numbers, the Fibonacci sequence, and the golden ratio, also known as phi. Specifically, the author posits that if you take the arithmetic mean or average of all prime numbers or composite numbers that fall between two consecutive Fibonacci numbers, and then divide that average by the larger of the two Fibonacci numbers, the result closely approximates half of the golden ratio, that is, phi divided by 2. Section 2. Mathematical concepts, formulas, and relationships. The video introduces several key mathematical concepts to build its hypothesis. The golden ratio, phi, is defined as approximately 1.618033. The Fibonacci sequence is represented as f of n minus 1 and f of n, which are consecutive terms in the sequence. The math relies on isolating subsets of primes and composites that fall strictly between consecutive Fibonacci bounds. The arithmetic mean is calculated as the sum of the numbers in a subset divided by the quantity of numbers in that subset. The video claims a specific convergence behavior. The calculation for primes approaches the target value from the bottom side, that is, slightly less than the target, while the calculation for composites approaches from the upper side, slightly greater than the target. The core formulas presented at the end of the video are as follows. For primes, 1/2 of phi is less than or equal to the arithmetic mean of all primes in the interval, divided by f of n. For composites, 1/2 of phi is greater than or equal to the arithmetic mean of all composites in the interval, divided by f of n. In the results slides, the author multiplies the right-hand side by 2 to compare directly against the full value of phi, rather than half of phi. Section 3. Visual demonstrations, diagrams, and number patterns. The video utilizes both graphical and text-based demonstrations. It features a tool called POF spiral, short for primes on Fibonacci spiral, a graphical application displaying a Fibonacci spiral where numbers are distributed along the curve, with visual indicators highlighting the positions of primes and composites. Additionally, text mode results display raw data output from a console application. These slides show the bounding Fibonacci numbers, for example, Fibonacci of 13 equals 233, and Fibonacci of 14 equals 377, list the actual prime numbers found within that range, and display the calculated sum, quantity, and average for that subset, culminating in the final calculated approximation to phi. Later slides present comparison tables with data for much larger Fibonacci numbers, up to Fibonacci of 46, presenting the calculated phi p, the approximation using primes, and phi c, the approximation using composites, alongside the actual value of phi, demonstrating the pattern where phi p is less than phi, which is less than phi c. Section 4. Methodology and reasoning. The methodology relies on custom software development. The author created 2 applications to test the hypothesis. A graphical one called POF spiral, built using the Allegro 4.2 library, and a console-based one called PAX, primes, and composite subsets. The underlying algorithm involves generating Fibonacci numbers, using the sieve of Eratosthenes to identify prime numbers, grouping them into the defined subsets, and performing the arithmetic mean calculations. However, the author notes significant computational limits that halted further verification. Using the sieve of Eratosthenes consumed too much memory, hitting an 8 GB RAM limit, and the calculations reached the maximum limits of standard 64-bit variables in the C programming language. Section 5. Conclusions drawn. The author concludes that their hypothesis is correct based on the data generated by their applications. They assert that there is a definitive convergence to the golden ratio when applying their specific metric to subsets of primes and composites bounded by the Fibonacci sequence. They formalize this conclusion into the 2 mathematical inequalities presented on the final slides, offering them as a new math formula for others to use or investigate. Section 6. Notable claims about prime numbers and the golden ratio phi. The most significant claim is that prime numbers, often considered to have a seemingly random distribution, exhibit a highly structured, predictable relationship with the golden ratio when analyzed through the lens of the Fibonacci sequence. The claim establishes a specific Euclidean metric where primes and composites act as opposing forces or bounds around the golden ratio, with primes consistently pulling the average slightly below phi divided by 2, and composites pushing it slightly above. End of report.